Well, friends, my dear participants, I am going to talk about data frame. Actually, since R is developed by the two statisticians and they were Ross Ihaka and Robert Gentleman in the Department of Statistics, University of Auckland. So they have taken many terminologies from statistical concepts. Like data frame is the concept of frame which we construct when we begin with sample surveys. So here, in which the first column is the name of the respondent, second column, so that is characteristic, second column is the his age, so that is numeric, third column is whether he is male or female, so that is known as logical variable. So all these type of characteristic logical variables numeric can be combined into an object, and that is known as data frame. But here data frame is a kind of restriction of the listed data, because in listed data also you can combine a vector with a matrix with a data frame, but here all the it should be the structure of the data frame is always in the form of a matrix. But in matrix you cannot have column, say for example, if you have control T, say for example x is equal to matrix, say 1:4, 1:4 and n call is equal to 2. So here x is the form of numeric, but if you have a matrix like the elements are like this 1, 2, say z and 4. So here you are trying to mix character string with numeric. See what happens. Now print x. It converts all its elements into a character string. Now you cannot do any operation of matrices here. So this is the problem with the matrix. Here the first column is also character string and second column is also character string. But in data frame we can combine a column with a column of character string with a column of logical variables. So these are objects, a kind of generalization of matrices, generalization in the sense that columns can be of different types from each other. This flexibility is not with the matrices. Use data.frame to construct a data frame from vectors. See, here the first row color, it is red, yellow, so this is a character string. Second, numbers, it is numeric, and here more numbers, and now color number, and they are organized into a data frame. Colors is equal to colors. Here these are the column names of data objects. These are the color is the name and this is the value. Number is the name and this is the value. More numbers is the name and more name numbers is the. So here if you print these numbers, see what kind of object you are getting. So here it is color, number and more numbers. So the first column is character string, second column is numeric and third column is also numeric. So we can combine. Now what we can do, we can change these these names, change the names, row dot names, color number is equal to paste 0, row 1 is to 3. Paste function I have already talked. First I would like to explain paste. Actually it is paste, say for example S or even without S comma 1 is to 3 or paste C 1 comma 2 comma 3. So here it will paste these two things together. Here see here S1, S2, S3, and if we want to remove the space between them, you have to make use of paste 0, S1, S2, S3. So here row, it is pasting the row number, row 1, row 2 and row 3. So we are generating the paste 0 and just type print color number C. The row names is row 1, row 2 and row 3. It is because of this paste. Now extraction from a data frame, we can have row names, row dot names, we can change call names also, and say for example here color, number and numbers. So we can change the call names, control 2, and we are going to change call names is equal to C double quotes. Say for example we can have numbers, then no colors, we can have the colors, 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 and then the second column names is numbers, so we can have like numbers, and the third column name is, say for example we want to change this more numbers, like this. So now you just print color numbers. Here the names, column names has been changed. So this way you can use call names to convert the to change the column names, and we can make use of row dot names to change the name the row names. So this way we can see. Now extraction from a data frame. See here color names C1 comma 3. So that means we are selecting first row and third row, and after comma we are not writing anything. So that means all the columns are getting selected. ठीक? And we can assign, say control 2, so this is the object. We have selected first row and third row and all the columns. Now we can assign them to another object, say for example df2, data frame 2, and we can deal with data frame 2 separately. So here this is data frame 2. So this way we can select column, and there is one more way using dollar operators to select by names, like color numbers. If we are using dollar, so here colors, so we have selected colors column, and if we are going to write score and colors and then numbers, then we are selecting numbers 1, 2, 3, and more numbers, we can select, so we can select them. So this is another way by using the dollar operator and name. See, there is another way using subscript, comma, C. You can use numbers, so it will select numbers column, and then colors. So colors name is COLORS, colors. So it will select, since we are putting after comma, that means column selection, and it is selecting the numbers column and colors column, and order is also changed. So first column will be number and other column will be, see here, first column will be number and we have shifted colors there, and we can assign this to an object, say for example A3 or DF3, and we can enjoy with A3 now. So this way we can make data changes. Now I shall talk about data import and export. The concept of import and export is thoroughly explained in our manual, and that is introduction to that is the our manual data export export. Reading data from Excel. Excel is a very popular spreadsheet software for entering data. Most of the users come with the data entered into Excel and want data analysis to be done in R. Following steps are required. Number 1, enter your data into Excel's spreadsheet. Save it as comma delimited value, say d1.csv file name. Read it into R by using read.csv and d1.csv. Save it into R as R object. Write.csv and d1 is this is the data object which has been created, and it has been saved into the file d2.csv, and row.name is equal to false. Note that when you enter the data into Excel spreadsheet, the first row should be the variable names. These names should not be fractured names. For example, plant height is fractured name. It should be plant height. As an example, consider the following data need to be entered into Excel sheet. So we have already entered this data into Excel sheet and we have saved it into as CSV file. So here this file is there, see d1.csv. So this file is, this is the Excel sheet we can look into this. This is the Excel sheet. View the file. See, this is the Excel sheet, and we can call this data into R by using the function read.csv. So here data has been transferred from there. Then we can make use of write.csv to save in a file, and that is d2.csv row.name is equal to false. And we can read them by using the function read.csv, and this is the d2. If we will write row.name is equal to true, it will have row names also, which we don't want. We want row.name is equal to false. Get summary of d2. See what summary it is giving. Height, it is minimum height, first quartile, median, mean, third quartile, maximum. And for the weight also, it is minimum, first quartile, median, mean, third quartile and maximum. And gender is a character type, so it has length 6 and class is character, mode is character. See, R has a very powerful interface with other systems. One can import data from other packages by using the package foreign. Similarly, one can save output to the systems too by using the function write.foreign. A set of columns below, a set of commands are below. Library foreign. So this is to load the library. To get the help about this thing, help pack is equal to foreign. Pack is equal to foreign. Foreign. Oh, it is not available. Yes. So, library foreign. Then we are using temp file. And then code file, it is temporary file. Write.foreign trees data object, data file, code file dot packages is equal to SPSS. So now we are writing, now we can run this file, data file, show data file. So this is the SPSS data file. This is the SPSS data file of trees. Now similarly, we can see the code file also. So this is the code file of SPSS which has been generated. So we can get code file as well as data file. So I am keeping this. Although these things are not needed, but it is just to have interface with code and other things. Now reading data from SPSS. We can read data from SPSS into R very easily as SAV is equal to read.spss. It is from the package foreign read.spss. File is equal to SAV. And here SAV is in the system files, system.files. it is electric.sav package is equal to foreign. So, we are extracting, we are reading the file from there, and then we are reading it as a file in SPSS. See the structure of the data. See, this structure looks very odd because it is in the listed data frame form, listed data format. So, to convert into a data frame, we have to give the additional argument 2.data frame is equal to true. So, 2.data frame is equal to, now see the structure of the data, it is data frame, it is data frame now, and you can look the header part of the data, it is header part of the data, and to look into the tail parts, it is tail part of the data. So, now this data has been converted into a data frame from SPSS, and we have read it from SPSS, and we can make use of this data frame, and you can get every summary results and other things. Reading data from Stata. Stata is also very popular software which is mostly used by the econometricians and others. Among economists, it is more common, Stata. So, one can read data from a Stata file into R. An illustration is made with Swiss data available with the package data sets. The functions read.dta and write.dta, these are the functions used to read data from. Say for example, here head Swiss, Swiss is a data which is available with the we can get help Swiss. So, it is Swiss fertility socio-economic indicators 1888 data, and this data is available with the package data sets. See, standardized fertility measure and socio-economic indicators for each of the 47 French-speaking provinces of Switzerland at about 1888. So, this is the data available with the package data sets. Now, we can look into, this is the tail of the data, head and tail, and then we can look into the structure of the data. Structure of the data is like this. It is a data frame of 47 observations and 6 variables. Variables are fertility, numeric agriculture, then examination, then education, then Catholic, then infant mortality, etc. Now, we require foreign package and write.dta, and file is equal to swiss2.dta. Now, we are trying this data to write into the format of Stata. So, write.dta is the function in foreign package, Swiss is the object, data object Swiss, and file is equal to Swiss dot. Now, we can read this data into R by making use of read.dta, swiss.dta. Read.dta is the extension, and we can read this, and this is the data. So, this way we can have interface with Stata package also. The best strategy is that you download .dta file into the working directory, working folder, and then use the function read.dta as we did above. This suggestion has been made into a great book on modeling, and that is by Gilman and Hill, and the title of the book is Data Analysis Using Regressions and Multi-Level Model, and there is a package by Gilman and Hill in R, and that is that package is ARM, and its latest version has also come, and that is R stand ARM. That is the ARM version has been changed into R into stan also, and the package is R stan ARM. So that is a great book to read on data analysis. Reading data from internet. See, suppose one can read data which is available on internet and the path is https goo.gl udv12g, and actually this data is available on the website of the book, and that book is R for Marketing Research and Analytics. That is a great book to read about marketing research and analytics. So this data set is there, and we can have df1 read.csv, and here you have to give just path of the data and make sure that your system is connected to internet. So this is the path, complete path. Now the data has been transferred, it is reading. Yes, now we can read data from a file on internet, and I have already told you about this file, that it is this is the data set which is available with a great book, and that book is R for Marketing Research and Analytics. So I am just writing the path of the data, and it is https lu gl ugv. So make sure that your system is connected to internet and you just run this. See, the data has been read and you can see the header part of the data. So this is the sales data. This data, this is the sales data. Similarly, data available on this path, that is a great data scientist, he is J.R. Lander, and he has made this data available on his home page. So we can first print the path. So this is the path, and then file is equal to read, and we can see the tomato data which is available on J.R. Lander, round, tomato, price, source, sweet, acid, etc. See, we can, if we want to use read.table, we can use read.table, file is equal to the URL 1, header is equal to true, and sep is equal to this thing, and then use header file. Note that when you run these commands, your system must be connected with internet. This is the requirement for generating documents also. Alternatively, you can save these data sets into your working directory and use read.csv to read them. Note most of the topics covered in this document are taken from these are the book of Brown, a first course in statistical analysis, and Venables 2009. Student may refer to these books for further reading. And I can show you these documents here. So this is the PDF document. Control end.